Page 93, we're going to continue lesson 2-2 on determining unit rates with ratios of fractions. So on example 2, Bronwyn mows the lawn every other weekend. She can mow 12,000 square feet in 2/3 of an hour. The lawn is 36,000 square feet. How long does it take her to mow the entire lawn? So different ways we could do this. One thing is what the book's doing. They've got 12,000 square feet in 2/3 of an hour. They're multiplying that by 3/2, which basically is the same thing as if you did 12,000 divided by 2/3. Now, if you did 12,000 divided by 2/3, just remember dividing fractions. Keep change reciprocal. Reciprocal. That one. So that you can see that ends up doing the same thing as what the book's doing there. Like we've said before, if you just take your two numbers and divide them, that'll give you a unit rate. In this case, square feet per hour. So they divided that out. They got 18,000 square feet per hour. And then probably what I would do at that point is just take 36,000 divided by 18,000. See how many 18,000s we have in 36,000. And it comes up to be 2. So it'd be exactly 2 hours. When we do these problems, our answers don't always have to come out evenly. A lot of these, they're going to be nice to you and make them come out as whole number answers. But again, that doesn't always have to be the case. And you can see over in the table here kind of a progression how they got towards getting their answer. Another thing you might notice on this one is 12,000 to 36,000 actually would be 3 times as much. So we could simply just take 2/3 times 3. So 3 is like 3/1. And multiply that. And that's actually going to be a simpler approach on this problem. But again, not always going to be the case that we'll have that nice of a pattern to get towards our answer. So the try it every other weekend. Bronwyn's brother Daniel mows the lawn. He can mow 15,000 square feet in 3/4 of an hour. Who mows the lawn in less time, and explain. So here's his information. So if we just divide these out, that'll give us the unit rate for Daniel's rate of mowing the lawn. So that's like 15,000 over 1. Keep change reciprocal. And we're doing feet divided by hours, so our answer is going to end up being in feet per hour. So if we divide that out, it would be 20,000, which means 20,000 square feet per hour. Back on example 2, Bronwyn, the rate for hers was 18,000 square feet per hour. So then from this we could say that Daniel mows the lawn in less time. Okay, regardless of the size, his unit rate's higher, and so he's going to mow faster. Example 3, Omar knows his friend Chris lives 3/5 of a mile away. How far is the school from his house? Okay, so kind of a compound problem here. So if Chris lives 3/5 of a mile away, on the map, it's represented by 3/4 of an inch. So 3/5 of a mile is represented by 3/4 of an inch. It's not a very good scale for us to work with. It'd be nice to know how much 1 inch on the map is. So you can either write it this way, or you can have these reciprocal of this basically. But the idea is we want to know what 1 inch is. So if you do 3/4 divided by 3/4, you'll get 1. If you divide something by itself is equal to 1. So 3/5 divided by 3/4, keep change reciprocal, becomes 3/5 times 4/3. If you multiply that out, that's going to be 12/15. And we can reduce that down to 4/5. So what that tells us is on the map 1 inch is equal to 4/5 of a mile. Having that unit rate is going to make things a lot easier for us now to figure out the distance to the school. The distance to the school we can see on the picture is equal to 2 inches. So if 1 inch is 4/5 of a mile, 2 inches would be twice as much as 8/5 of a mile, or 1 3/5 miles. Okay, and again, once I get this unit rate, I don't care what the distance is to the school. Okay, you can tell me it's 7/8 of a mile, whatever, non-nice number, doesn't matter, because I know if I have a 1, I just take 1 times whatever the number is, and that will give me that distance. So if we look at the try it, Sonoma bikes 5 miles to Paige's house. On a map, they measure the distance as 5/6 of a centimeter. The same map shows that the mall is 3.5 centimeters from Paige's house. What is the actual distance between Paige's house and the mall? So we could just try and do a proportion here and figure out that missing number, see if we have a nice pattern. The other thing is we could try to figure out on a map what 1 centimeter is equal to. So it's 5 miles is 5/6 of a centimeter. And again, we're going to try and figure out what 1 centimeter is. So if we divide 5/6 by 5/6, that'll tell us what 1 centimeter is equal to. Again, if you divide something by itself, you always get 1. So like we've been doing here, we can keep change reciprocal. At that point, you're multiplying, so if you want to reduce like factors, you can. You don't have to. So this is 30 over 5, 35ths. If you divide that as 6. So that means 6 miles are represented by 1 centimeter, or 1 centimeter equals 6 miles on the map. So it's up to you. I'm just going to flip-flop those. This is usually how I'll write them when I'm given a nice unit rate like this. And then we're trying to figure out for 3.5 centimeters what that distance is. So to get from 1 to 3.5, we have 3.5 times as much. So we'll take 6 times 3.5. You guys know half is a nice decimal, so if you want to put that as 3.5 and multiply that out, you can. If you don't put it as a decimal, just remember you'll need to change that to an improper fraction and work it out. Either way we do this, we should get 21. If we do it this way, 6 times 7 is 42, half of 42 is 21. Or you do the decimal and you get the same thing. Remember, move your decimal over 1 spot. So that would be 21 miles would be the actual distance. So if we look at the do you understand number 2, Jacob mixes 1/3 cup of yellow paint for every 1/5 cup of blue paint. To make green paint. So how many cups of yellow paint are needed for 1 cup of blue paint? So I'm using black instead of yellow there just because the yellow doesn't show up quite as well maybe. So this is what we've got. They made a table. They didn't have to do this, but 1/3 cup of yellow for 1/5 of blue. So how much do we need for 1 cup of blue? So what we might look at is if we have 1/5 of a cup, we're trying to get to 1 cup of blue paint. So we could divide by 1/5, or you can say multiply by 5. If you do keep change reciprocal, you're going to get the same thing either way. So if we do that, then with the yellow paint, we're looking at 1/3 divided by 1/5. So 1/3 times 5, if you want to just multiply that straight across. So that would be 5/3, and 5/3, we can divide that out. Change it to a mixed number, which would be 1 2/3. So 1 2/3 cups of yellow that we would need to get that same color of green. Number 4, Claire boarded an airplane in Richmond, Virginia and flew 414 miles directly to Charleston, South Carolina. Total flight time was 3/4 of an hour. How fast did Claire's airplane fly in miles per hour? So 414 miles in 3/4 of an hour. If we divide 3/4 by 3/4, we'll get 1, which will tell us how many miles per hour, how many miles per 1 hour. So 414 divided by 3/4, keep change reciprocal. So 1656 over 3, and if you divide that out, is 552. So 552 miles per hour. And if you want to say, if you want to say mph for miles per hour or something is fine also. And that might seem, that's crazy. But yeah, planes can go pretty fast. So even though it might seem like that's not reasonable for an airplane, it is reasonable. So if we look at number 6, Jed is baking shortbread for a bake sale. Recipe calls for 1 4 cups of flour and a 1/2 stick of butter. How many cups of flour will Jed need if he uses 3 sticks of butter? So like we've been doing, if you want to get your unit rate on this, you can. This one, the numbers aren't too bad that you guys might be able to kind of just think through the process. So if we get a unit rate here, a 1/2 divided by a 1/2 would be 1, or times 2, which is what we're going to end up doing anyway. So that tells us for 1 stick of butter how much flour we need. For this one, remember you need to change 5/4 to improper fraction or fraction greater than 1, and then keep change reciprocal. Don't try and go too quickly working this out. So if we work that out, it comes out to 5/2, which is 2.5 cups of flour for 1 stick. We need to find out for 3 sticks So 3/6 would be 3 times as much. So we can take 2.5 times 3. If you want, again, that's a decimal. Pretty nice. You could do is 2.5, and then 2.5 times 3 would be 7.5 or 7.5 cups of flour. And either way is okay with that one. Again, if the decimal isn't very nice, it's probably better to just keep it as a fraction, but in this case we can get by with that. The other thing you could do on this problem is if you recognize if I've got a half a stick of butter and I'm trying to get 3 sticks of butter, 3 sticks of butter is equivalent to 6 halves of butter, 6 half sticks. So you could just directly take the half stick that we were given and multiply it by 6. So 1 1/4 times 6, or 1.25 times 6, and you'll get that same answer. So on workbook page 24, number 10, yesterday Noah ran 2.5 miles in 3/5 of an hour. Emily ran 3 3/4 hours in 5/6 of a mile. Anna ran 3.5 miles in 3/4 of an hour. How fast in miles per hour did each person run, and who ran the fastest? So we're going to have to calculate all 3 of those out then. When you're doing this, if you wanted to, we could see if the decimals are not too bad. We could work off of that if you wanted. 2.5 we know is 2.5 miles. 3/5 of an hour, you could just take 3 divided by 5. So that'd be 6/10 of an hour. So if you wanted to at this point, you could say, well, to get 1 hour, we'll just divide both of these by 6/10. You can actually then, if you have your calculator that you're allowed to use, which I'm allowing you, you could just take 2.5 divided by 0.6, and that'll directly get you to that answer. So if you do that, you're going to get 4.16, and the 6 is repeating. The last digit on the calculator is a 7, but that's just rounded off. What we can do if we wanted to, this is potentially good enough for what we're trying to figure out here, but if we wanted to be a little more specific and not have that repeating decimal on there, what you can do is you can hit, with that answer still on the screen, you can hit the second button, which is in the top left. It's probably blue or yellow or something. And then just down and to the right of that, you have a PRB button. PRB stands for probability. That's not what we're doing. We are doing the secondary function of that button, which is right above the PRB button. If you look, it has an F and D with arrows. That's going to change that between a fraction and a decimal. So if we hit second and that F to D, and on your screen it should look something like this. And what that means is 4 1/6. So that's changed that over to a mixed number for you. Again, if you don't have a calculator and you're not going to give a decimal answer, it'd probably be best just to keep those as fractions and work it out that way. But anyway, so Noah would be, as a mixed number, would be 4 1/6 miles per hour. And then we'll do the same process for the other two. So for Emily, it's 3 3/4 miles in 5/6 of an hour. So this, you might recognize 3 3/4 the same as 3.75. And if you wanted to, we could get by doing this all in the calculator just with putting the 5/6 in parentheses. So if you do 3.75 divided by, and then in parentheses 5 divided by 6, and that should give you 4.5. So 4.5 miles per hour, or 4.5 miles per hour for Emily. And then the same idea for Anna. So 3.5 miles and 3/4 of an hour if you wanted to do decimals. 3/4 is 0.75. So if we divide both of those by 0.75. So if we divide that out on a calculator, we will get 4.6 repeating, a 7 at the end, but that's rounded off. And we could change that over to a mixed number using the steps we just talked about. Second, and then the PRB button changes between the fraction and decimal. So that would be 4 2/3 miles per hour. 0.6 repeating is pretty common, so you guys might get used to that one. So now we can compare these three. 4 1/6, 4.5, 4 2/3. So just using reasoning there, we might look at it that Anna's the only one that's, the 2/3 is over half, 1/6 is less than half, and half is equal to half, obviously. So 4 2/3 would have to be the fastest, so then we could say that Anna is the fastest runner. So this gives you an idea of how to work with unit rates with ratios of fractions.